So at the end of the last video, I said that this was going to be our next problem. Some of you may have tried this on your own already, in which case good for you, and we'll hope your answer checks. Some of you may have preferred to work through it together first. So let's just remember that anything we do to x before we evaluate the trig function is going to affect things horizontally. And anything we do after is going to affect things vertically. So I'm actually doing two things vertically, but just one thing horizontally. Okay. So if I look at the vertical transformations, remember that what we're going to do is we're going to first of all graph y equals 2 plus 3 sine of x minus pi over 3, where this is horizontal and this stuff is the vertical transformations. We're going to graph that as a dotted curve and then flip the bumps. Okay. So if I look at the vertical stuff, I know that sine normally has a high value of 1, a middle value of 0, and a low value of -1. Okay. After I evaluate sine, I'm going to multiply it by 3. So that's going to move the high up to 3, the middle stays at 0, the low is -3. And again, I'm not drawing this to scale. If I were, this would be 3 times as tall. I'm just using this to record what my important y values are. And then we're going to be adding 2 to it. Do be careful. We're adding because the 2 is positive. If this were a -2, I'm adding a -2 to it. So I can always view it as addition, but I want to look at the sign in front of that number. So that's going to shift things up 2. So my new high value is 5. My new middle value is 2. And my new low value is -1. Okay. So these are the y values that I'm going to be marking off. And then for the x values, I know that sine does its thing once as the input varies from 0 to 2 pi. Whoops. And the input is x minus pi over 3. So I'm just going to add pi over 3 to each piece here. So I'm going to have pi over 3 less than or equal to x less than or equal to. Now over here I've got 2 pi. I'm going to just remind myself that that's the same as 6 pi over 3, because 6/3 would reduce to 2, plus pi over 3. That's going to be 7 pi over 3. Okay. Now, it should be that the period is actually still just 2 pi, because I only change the period if I multiply x by a number, and I'm not doing that here. Let's confirm that. 7 pi over 3 minus pi over 3. Yep, that's 6 pi over 3, which is 2 pi. Okay. So the period is still 2 pi, which means the increment is just a quarter of that. So that's going to be 2 pi over 4, or pi over 2. So I'm going to need to start at pi over 3 and count over by pi over 2 until I hit 7 pi over 3 when I'm going to stop. Okay, so let me just write that down. Start at pi over 3, end at 7 pi over 3, and the increment is pi over 2. I need to write that down because I need to clear the board if I'm going to actually do this. Okay, so here's my x-axis. Now before I mark this off, I'm noticing that I'm starting at pi over 3, but I'm having to add pi over 2. It's going to be a whole lot easier if I have a common denominator. So common denominator would be 6. Pi over 3, if I multiply that by 2 halves, that's going to be 2 pi over 6. Okay. And pi over 2, if I multiply that by 3/3, that's going to be 3 pi over 6. So what I'm going to do is I'm going to just mark off a bunch of tick marks here. So I want to make sure my scale is correct. Each of these tick marks is pi over 6, because that's what these numbers have in common. Okay. So I'm starting at 2 pi over 6. Now I know that reduces, so what I'm going to actually label it as is pi over 3. But what I'm going to do down here, I'm just going to record, that was 2 pi over 6. I'm going to record the fractions not in lowest terms here and then just erase that at the end. Okay. All right. I'm adding 3 pi over 6. So if this was 2 pi over 6, 3, 4, 5 pi over 6 is going to be the next point that I care about. Okay. I'm going to add, and that doesn't reduce. Okay. I'm going to add 5, 6, 7, 8 pi over 6 is the next one. But that one will reduce. That'll reduce to 4 pi over 3. So that's how I'll actually label the axis. Okay. And then let's see. This was 8 pi over 6 plus 3 is going to take me to 11 pi over 6. That does not reduce. Plus 3 more pi over 6 will take me to 14 pi over 6, which does reduce to 7 pi over 3. And that was supposed to be my ending point. Okay. So notice when I'm adding fractions with different denominators, really helpful to not only get a common denominator, but make the tick marks on the x-axis correspond to pi over that common denominator. Okay. And I actually don't want to point there, do I? Because 0 is no longer one of my important y values. Okay. So on the y-axis now, I'm going to mark off -1 and 2 and 5. I like to draw in dotted lines at those heights. That's just because I don't have graph paper here. And if I had graph paper, those would be the grid lines that I had there. Okay. And then I'm going to remember that if I'm graphing a sine function, sine starts at a middle value. So my starting x value is pi over 3. That's at a middle y value of 2. Then it goes up to a high value. So I'll have 5 pi over 6, 5. Then it comes back to a middle value. So I've got the point 4 pi over 3, 2. Down to a low value. So 11 pi over 6, -1. And then back up to a middle value. Okay. Excellent. So I could connect the dots with a dotted curve like so. Now, what I need to remember here is when I'm doing these vertical transformations, I would add that too after I had already taken cosecant. So I don't care where this graph is 0. If I had shifted this thing up 5 points, it would never be 0. What I care about is where secant was originally 0, which corresponds to when I'm on at this middle point. So I'm going to draw my asymptotes whenever my y value is at that middle y value, whatever that has moved up to. So I'm going to have an asymptote at pi over 3. I'm going to have an asymptote at 4 pi over 3. I'm going to have an asymptote at 7 pi over 3. And then I'm going to flip the bumps. Okay, so there's our graph of this transformation. Okay, I'm going to put another problem up. I would encourage everyone to try this one on your own before you watch the next video. Okay. If you're not feeling confident you need to watch the video, that's okay. But I'd encourage you to at least think about it. Try it if you can. And even if you need to watch the video, think about it first so that you're coming into the video with some specific questions. Let's try this. Y equals 3 minus 2 secant of, let's go with pi x. Okay, so I want to graph this. I want to graph exactly one period of this, and we'll take a look at that together when we come back.